Alright, now to solve this problem, we first need to realize that this problem is a quadratic function in standard form, which means it could be written this way. Now, when we're looking for the roots or the x-intercept, we need to let y equals to 0. So our whole equation would have been 0 equals, well, we have to let y equals to 0. So now we have this equation right here. Okay. So once we do that, we can easily factor this out and solve for x. But it turns out that if you use your traditional factoring method, it won't work. So what we have to use is the quadratic formula, which means x is equal to negative b plus or minus square root b squared minus 4ac divided by 2a. Being that since it's in standard form, I should easily be able to identify what my a value, my b value, and my c value is. My a is 3, my b is negative 6, and my c is 5. Just matching the variables up, right? Now you just substitute the values for the letters and solve for x. Alright, once you've written it all out, you know that in order to solve this, we always work with the radical first. So let's work out the radical. We know that this will be 36, right? Negative 6 times 6. Negative 6 times negative 6 is 36. Minus 12 times 5, which is 60. This becomes positive, right? Now we know that 36 minus 60 is negative 24. And I think we can just stop from right here, because since we haven't introduced ourselves to complex number, we know that we cannot square root a negative number, and so this is undefined, this part. Okay. Since we can't really define that, so that means there are no real roots. Alright, so how do I graph this? Well, there are a couple more questions we have to answer, right? So we need to still find the axis of symmetry. So to find the axis of symmetry, we use the formula, quite like the quadratic equation, except without the square root part. So you have x equals to negative b over 2a. Just ignore the square root part, right? Substitute for the values. Alright, and you simplify, and you get 6 over 6. So x is equal to 1. It's very important that you put x equals to 1. Now let's go ahead and put that on your graph. After you find your axis of symmetry, we need to find your vertex. Let's do that over here. And remember, to find your vertex, you already have, the axis of the vertex lies on the axis of symmetry. So you know the x-coordinates is already 1. You just need to find y. So what you're going to do is you're going to substitute that 1 into your original equation. So we do the parentheses first. 1 times 1 is 1 times 3, which is 3, minus 6 plus 5. And when you solve this whole thing out, you should get 2. And so your y coordinates is 2. You're going to put it right here. So your vertex is on 1 and 2. And that's your vertex. Alright, and we haven't gotten the complete picture yet. We still need to find the y-intercept. And again, to find the y-intercept, we know the y-intercept is always on the y-axis. So because it's on the y-axis, we know that the x-coordinates is always 0. We just need to find what the y is, right? So that means I'm going to let x equal to 0 and solve for y by plugging x back into the original equation. Okay. So now we have y equals to 3 0 squared minus 6 times 0 plus 5. Alright, 0 squared is 0, 0 times 3 is 0, 6 times 0 is 0 plus 5, and so your y-intercept is 0, comma 5. So let's locate that on your graph. 0, 5. Being that a parabola is symmetrical through the axis of symmetry, I know that if this is 0, 5, there should be another point at 2, 5 right here, which is now equidistant to the axis of symmetry. Now I can complete my graph, my parabola, draw it as symmetrical as possible. Alright, and let's interpret our findings. Okay, we found out that the roots are undefined. That means no real roots. If you look at what we've drawn here, right, the graph never touches the x-axis, so there aren't any roots, real roots, and everything else is there. Alright, good job. Thank you.